Good morning, student. Do you hear me?
Good morning, sir. Yes, we can hear you.
Good morning, sir.
Good morning. So last class we have discussed the computer vision in image processing. That is, we have discussed that and its applications, its visions. So computer vision is the same. It is actually a branch of artificial intelligence (AI), and it is enable computer to interpret and extract information from image and video similar to human. I've already discussed the application in almost all the sector. The use of AI or computer vision, you will get nowadays oil and natural gas, hiring process also, video surveillance, in construction we have discussed, healthcare also, agriculture, military, industry, automotive, and automated lip reading. Then the fundamentals of image formation. As you know, the your screen is a 2D, and in the real world the image, the object is a 3D, so there should be a mapping from a 3D world to the 2D view. So image formation is an analog to digital conversion of an image with the help of a 2D sampling and quantization technique that is done by the capturing device like cameras. So there is a two method, you know, that is a conversion of a analog digital to digital conversion, basically done in two techniques. One is sampling and is another is quantization. So we see a 2D view of 3D world. 2D view. Why we are in 2D view? As it is a 2D screen. In the same way, the formation of the analog image took place. It is basically a conversion of the 3D world, that our analog image, to 2D world, that is our digital image. Generally, so there is a frame grabber is used, you know, and the mapping of 3D world object into 2D digital image plane is called imaging. So imaging is required to uh, form a form of image. Uh, for these purposes, uh, the lenses and mirror are crucial in focusing the light coming from the 3D scene to produce the image on the image plane. So when you capturing an image or object, there is a lenses or mirrors. Similarly, we know that there yeah, our eye also look like it also capture image so that we can view it. So the eye, we have also a eye lens. So this system define how light is collected and where it is directed, and consequently affects the sharpness and quality of the image produced. The goal of image sensor like the CCD or CMOS sensor, there are sensor are used are to simplify transform the optical image into the electrical signal. The sensor differ by sensitivity. The resolution that they deliver affect the image as a whole. So the resolution also plays a vital role. So the image or picture having high resolution is a better quality, high quality. So resolution and sampling is also an important. It uh, uh, defines the quality of an image. So resolution is defined as the sharpness of an image, and it occurs technically as the number of pixel an image can hold. So the number of pixel depend the quality of the image. If the number of pixel in a picture is more, so it is better quality. If the pixel size is large, so if pixel size is large, so a picture contain less number of pixel, and that is the decrease in quality. So sampling is is the act of taking a sample or decretizing the digital signal. As you know, there are two processes. Sampling basically associated with the location of the image, and sampling is the gray label value or color value of that pixel. It can be seen that the higher resolution and appropriate sampling rates are required in order to provide detailed and accurate image. Image processing. Image processing can be described as the act of modifying and enhancing digital image by using algorithms. So it has suitable software. Now we have preprocessor tools. We have the predefined tools. So the software is there. So in that using that software, using that algorithm, image processing operation takes place. Pre-processing include activity like filtering, noise reduction, and color correction that enhance image quality and information extraction. So you know that there are if so in image processing we uh, use filters. Different type filter we have discussed. The filter used for to increase the enhance the quality of an image. Noise reduction. You know that the noise reduction, if there any noise are there, suppose some pixel value is missing, some is spurious, and some there is a blurring or more brightness. So we use the image processing to reduction of noise. Besides that, also color correction. We can use to change the gray label value from one value to another value. Mm, So there are please recall there are clipping, thresholding. This purpose used to change the gray label value that enhance the image quality and information extraction. In digital image, a frame grabber is placed at the image plane, which is like a sensor. So it aims to focus the light on it, and the continuous image is pixelated via the reflected light by the 3D object. The light that focus on the sensor generates an electrical signal, and each pixel that is formed may be color or gray depending upon the intensity of the sampling and quantization of the light. So if you know that a pixel has two value, that is why it is called the image in a 2D. It is a location and it is gray label value. So that is the intensity value. So the color of a pixel depend upon its gray label value. It is intensity. All these pixels from a digital image, the density of these pixel determine the image quality. As you know, the density of an image pixel determine the image quality. If the picture contains more number of pixel, its quality is better. Okay. So the more the density, the more is the clear and high resolution image we will get. So density of the image pixel depend upon the quality of the image. And this is already know forming a digital image, sampling and quantization. I will not required. And this is advantages: improve quality, enhance flexibility. I have discussed. I think high storage capacity, easy sharing and distribution, advanced analysis. And although there are some disadvantages, data size, image noise, dependence on technology. So technology depend. If technology fails, so there should be some problem. Also privacy concerns, data loss risks. If then introduction to object detection using image processing. As you know, object detection to detect the object is a crucial task in computer vision that involves identifying and locating object within an image or video. Suppose there is a audio, there is a video you get. You detect an object from that image is known as object detection. Suppose you want to detect a vehicles in a video or vehicles in a still image, so it is called object detection. This task is fundamental for various applications, including autonomous driving, video surveillance, and medical imaging. Suppose there is an ultrasound report, and doctor want to focus on the suppose there is stone in a stomach of a patient, so they want to view the detect the stomach, sorry stones in that picture. This article develops into the technique and methodologies used in object detection, focusing on image processing approaches. Key concept of object detection: object localizations. This involves determining the location of the object within an image by drawing boundary boxes or around them. Okay. So, determining the location of the object in that image. So, how to no, detect? That is by drawing boundaries or boxes. Object classification. This involves identifying the category to which detected object belongs. So, in which classes object belongs? Suppose there are vehicles, and, several animals. So, this is which category the object belongs. And boundary boxes. There are rectangular boxes used to define the location of object within an image. So, you know that you, we have an image. After one or two slides, we will see there are some boxes are drawn to detect the objects. Uh, After detecting, then the image recognition. How to recognize the object in an image? Uh, it is a task of identifying object of interest within an image and recognizing which category of image belongs to. When we visualize see an object or scene, we automatically identify object as different instances and associate them with individual definition. Visual recognition is the highly complex task for machine to perform, requiring significant processing power. So, to recognize the object in an image. Image recognition work is a long-standing research problem in the computer vision nowadays also, while different methods to imitate human vision involved. The common goal of image recognition is classification of detected object into different categories. That is determining the category to which an object belongs. So therefore, we also refer to deep learning on object. We have a deep learning process how to recognition the object of an image. So this process is known as image recognition. So machine learning, in particular deep learning technology, has achieved big success in many computer vision and image understanding tasks. Deep learning image recognition method achieve the best result in terms of performance, that is frame per second or short known as FPS and flexibility. So basically, to recognize the object an image is known as image recognition. You see here. So image recognition using the most powerful object detector. You see, there's a person. It also recognize the dining table, cup, books, laptop, keyboard, cell phone, and you see some boxes are there in different color to recognize the same. That is who. You see there are same color. Suppose the person has one color, and you see the box. So rectangular boxes are drawn. You see there are two cup. Uh, they are having the same rectangle. The color of the rectangle border is same. The line is same. You see book. There is book. All the book has the you see pink color, and it is also already it's in there. So this is the using a object detector is used to image recognition. So this is an image. You see how the image is recognized, and the process is known as image recognition. So sometimes there's a confusion between image recognition and object localization. Object localization is another subset of computer vision, often confused with image recognition. Let us let us see what it is. Object localization refer to the identifying the location of one or more object in an image and drawing a bounding box around their perimeter. However, object recognition does not include the classification of detected object. So it is only identify that and draw a bounding box around their perimeter. But object localization, what does means that object localization does not include the classification of detected object. So it does not include the classification, but it is only identifying the location of one or more object in an image and drawing the boundary box around their perimeter. You see, this is an example of face detection. So example of head detection with deep learning you see on a digital image. So here the detect the face in an image you see drawing the rectangular. You see here. There's also difference between image recognition and image detection. Let us see how. The term image recognition and image detection are often used in place of each other. However, there are important technical differences. That is, image detection is the task of taking an image as input and finding various objects within it. So it takes the input as an image is taken as an input, and in image detection we only find the various objects within it. For example, is a face detection, where algorithm aim to find face pattern in image. When we strictly deal with detection, we don't care whether the detection objects are significant in any way. But the goal of image detection is only to distinguish one object from another to determine how many distinct entities are present within the picture. Thus, bounding boxes are drawn around each separate object. Okay, each separate. City only it detect the face, but the image detection is you see image detection distinct the entity are present. But on the other hand, image recognition is the task of identifying the object of interest within an image and recognizing which category or class they belongs to. So the you see the goal of image detection is only to distinguish one object from another to determine how many distinct entities are present within the picture. Thus, bounding boxes are drawn around the separate object. But in image recognition, is the task of identifying the object of interest within an image. Okay, so it is associated with the fix or the object which you are interested to search within an image and recognizing which category or class they belongs to. Okay, so image detection is used to only the distinguish of one object from another. But the recognition is one to recognize the identifying the object which you are interested within. You see here, real-time video recognition with the different car, truck, using YOLO VBA detector. You see, there are different type of vehicles. There are car and there are some truck are there. You see, and the video recognizing, that is your recognize your detection only detect the vehicles only. But you see in video recognition, that is it classification there, that is different vehicles are there. Car is there, truck is there. So suppose you are interested to view the trucks only, so you can view it. Let us see how image recognition work. How does AI image recognition work? That is how the image recognition is required. You know, image recognition is important topics or important feature in AI computer vision. So the conventional computer vision approach to image recognition is a sequence computer vision pipeline of image filtering, image segmentation, fixture extraction, and rule-based classification. We have already discussed some of them. What is filtering? What is feature extraction? Uh, however, engineering such pipelines requires deep expertise in image processing and computer vision. A lot of development time and testing with manual parameter tweaking. So that is why it reads manual processing, image processing. It takes lot of time. In general, traditional computer vision and pixel-based image recognition system are very limited when it comes to scalability of the ability to reuse them in varying scenario and location. So if you compare nowadays, the pixel-based image computer recognition system is limited. So that is why we are using machine learning or deep learning. Image recognition with machine learning, on the other hand, use algorithm to learn the hidden knowledge from a data set of good and bad sample, supervised or unsupervised learning. So you know that the sampling are different types. So some sampling is good, some sampling is bad. It will classify depending upon some component, some properties. This is a bad sampling. This is a good sampling. So you know that the process of sampling. The most popular machine learning method is deep learning, with a multiple hidden layer of a neural network are used in a model. So deep learning is a vast topic to discuss, but basically it is used for this purpose. That is your uh, object recognition. So you see, this is an image of video analysis with machine learning using YOLO V7, which is a detector, image detector. You see, so different person is there. And also it recognition the monitor, you see, is written as TV 0.40. These are number. It also recognize the clock. There's a clock. It also recognize that. The introduction of deep learning in combination with powerful hardware and GPU enable great breakthrough in the field of image recognition. So as you know, the deep learning, actual deep learning is a vast topic. how the different process are used in it for image classification and neural network face recognition algorithm achieve above human level performance and real time object detection. So the particular software and algorithm is used um, for the detection and recognition of the object in an image. Still, it is a challenge to balance performance and computing efficiency. So, hardware and software with deep learning models have to be perfectly aligned in order to overcome computer vision cost. So, there is a hardware and software uh, deep learning model have to be perfect aligned. That is, the cost is more, so that is why there should be some technique used for to reduce the cost. Therefore, the ability to always use the most recent algorithm has a direct costing application. The most powerful and efficient algorithm requires several times cheaper hardware and achieves several times better performance on equivalent hardware when compared to Lagrange algorithm. So algorithm is used for that purposes. So this is your uh, detection, uh, image detection and uh, recognition process. Then human vision system. So we know that our human vision is also a powerful like your capture, like powerful tools which capture pictures. That is, it has also some lens like your camera, and you can see the human eye is nearly spherical shape with 20 mm diameter on an average. So this human eye is 20 mm in an average. The three main part of the eye are the cornea and the sclera outer cover, the choroid and the retina. So these are the main component in our eye. You see here, this is the block diagram and different part of our eye, and each part are different to each other. The function of the lens are there, cornea is there, iris you see, eye iris is there, and blind spot is there, retina is there, which so choroid is there, and mm, uh, so these are different parts of eye, and each part has different function, and this is a block diagram. It is written that is what is the sclera is an opaque member that enclose the optical globe all around except at anterior end, which is covered by the cornea. The cornea is a top transparent cover of anterior chamber. Similarly, the choroid is the layer under the sclera. The membrane choroid contains a network of blood vessels. So the blood, you know that the blood vessel contains choroid. The blood vessel from the major source of nutrition for the eyes. So if the choroid is damaged or inflamed, it can restrict blood flow in the eye and resulting the serious damage on the eye cell. You may not see if the choroid is damaged. So because it provides nutrition to the eyes, so if it is damaged or inflamed, it can restrict blood flow. So if there is no blood flow in the eye, so you may not see anything. It damages our eye cells. So the role of the chloride is also to control the amount of light entering the eye as well as to reduce the backscatter inside the eye. So it is also control how much amount of light is entering to your eye. That is, we know that if light is very brighter, we cannot see it. So it control the amount of light entering the eye as well as reduce the backscatter inside the, and the chloride is divided into two parts. uh, The ciliary muscles, which relax the tighten to enable the lens to focus by changing its shape. The iris also there. This contract and expand to control the amount of light that enter the eye. So it controls also the amount of light. The lens is a transparent and biconvex. So we have eye lens, which is a transparent and biconvex structure that helps to refract light into eye so that the image is formed on the retina. So it is so adjusted that the image is always formed our retina. If the image is nearer to you, it adjusted so that the image is from the retina. If the object is far from you, also it is adjusted that the image is from on the retina. Okay, so lens is flexible and change shape to change the local length of the eye. So there is a focal length of eye. So focal length also, so it adjusted that the shape is changed to the focal length of the eye. This ensures that object at various distance can be focused upon and their image can be from the retina. So as we discuss, it is adjusted in such a manner that if you can see an object nearer to you, which is very nearer to you, also you can see an object which is very away from far from you, because it adjusted in such a manner that always the image is formed on the retina, so that we can view the object irrespective any distance. The retina is innermost membrane of the eye. So you know that we can view those image which is from our retina. So it lines the wall of the complete posterior portion of the eye. The retina can be thought as an image plane in the eye, since on properly focusing the eye on the object, light from the object is passed through the lens so that the image is formed in the retina. So if the image is always formed in the retina, so that we can see it. The retina consists of two types of cell called rods and cones. The cones are highly sensitive to color and around 6 to 7 million in human eye. Okay, so you see that is 6 to 7 million. The cones are located on the focal length, and two foci are there, which is the center portion of the retina. So there are two types of cells inside the retina. One is rods and there are cones. However, there are 75 to 150 million rod cells which are completely distributed all over the retina. So there are 75 to 150 million rods. The rod cell give the overall picture of the object in the scene and reduce the amount of details. Rods are also responsible for low light vision, also known as scostopic vision. That is, it also responsible for low vision, low light vision. While cones are responsible for bright light vision, also known as photopic vision. So you see the function of cones and rods are different. So the rods is responsible for low light vision, whereas the cones are responsible for bright light vision. So in our eye, the distance between the retina and lens, that is the focal length, varies from 14 and 17 mm as the refractive power of the lens increase from minimum to max. For nearby object, the lens is more strongly refractive. More, Moreover, the lens of the eye is very flexible, is flattened by controlling the muscles to enable the eye to focus on the distant object. If the object is far, so it is very flexible. It can be flatten the muscles to enable the eye to focus on distant objects. So you can view an object, either the object is very nearer to you or the object is very far to you. So this is human eye. Sometimes you get the questions about the human eyes. What is human eye, and write difference, how it is works, and you also have to write the different component of the human eye.
सर वो जरा फिगर दिखाएंगे.
फिगर नहीं, ब्लॉक दो ब्लॉक डायग्राम है.
अच्छा, ब्लॉक डायग्राम.
हम्म, ये आई का फिगर नहीं है. ओके, ये ब्लॉक डायग्राम बस दिखाना है, बस ये दिस पार्ट है. मेनली दो चार जो कोरेना है, इरिस है, और क्लोराइड, रेटिना. Okay, these are the eye lens. So these are the major component of our eye. So you have to write about those component only. then color fundamental. Yep, that's good. How the color is formed, different color is formed. Every color is defined using three qualities that are independent of each other. However, taken together, they define a particular shade of a color. So you know that our basic color is RGB, red, green, and blue. The other color is formed by combination of these three primary color in different ratio. So our three primary color is RGB, red, green, and blue. Let us see. The quantities are hue. It is a component of color is defined by the dominant wavelength. The wavelength range on the electromagnetic spectrum that define the visible color spectrum lies between 400 nanometer. Nm is nanometer. So the visible spectrum is between 400 nm. That represent the violet color is 700 nm. Violet color and 7 mm that represent the red color is can be you see the figure. You see the wavelength. Only the visible spectrum. The visible spectrum is you see uh, within this wavelength 400 nm where the blue color and the red color is 700 nm and the other color is in between them and the other color which is out of range of this spectrum is not visible. You cannot see the radio waves which has you see radio has 10 to power 9 to 13 nm. You cannot see the infrared which is wavelength 10 to power 3 that 1000 nm. We cannot view the X-rays. We cannot view the ultraviolet. It has 10 to power minus nm. So only visible spectrum which lies between only these rays we can view it. That is the red color and your blue color 400 nm. So this color spectrum which lies between this range is known as visible spectrum. We can view it in our eyes.
Sir, what is the figure under blue and green?
Blue and green means that is 4 nm. You see the wavelength spectrum having 4 nm is blue color.
So above in parenthesis, we have what, 436?
After this range that is 433 is blue color, exactly blue color. Okay, and if we or 446 is exactly green color.
Okay,
And
okay.
700 mm is exactly red color. The other color, suppose 496. Okay, 496 is the combination of blue and green. It lies between in between blue and green. Any color, blue and green.
Okay, so 436 is completely
Is blue
blue.
color. Blue
Yeah.
color.
Okay, okay.
Yeah. And 700 is completely red. And this is visible spectrum. You cannot view the color which is that is beyond of this range. Yeah, that is you cannot infrared, you cannot X-ray, you cannot view the X-ray, you cannot view the radio waves. So the only this the color has been the spectrum value in between this nm, we can view it, and this is a different color.
So what are the wavelengths of CMY in this spectrum? CMY, cyan, magenta, and yellow.
CMY CMY means a combination of this. It has some exactly wavelength. Okay, some values there. I do not recall that, but C has also a uh, wavelength. Okay, yellow color also has a wavelength. So every color has a particular fixed wavelength.
Sir,
That's what
in digital imaging, I've read that C is 1 minus B, I think. 1 minus blue
mm-hmm.
is.
Hey,
Yeah.
will you read after the slide is written that? Okay, we'll discuss about that. I think CMI model is here. After one or two slides, you will get CMI model.
That is
Saturation.
used for printing, right? Not pure
Hmm,
light.
hmm, hmm, hmm. You see, the saturation. The excitation purity of a color determined by the quantity known as saturation. It depends upon the amount of white light that is mixed with the hue of that color. A fully saturated color implies that is no white light is mixed with that hue. So it depends upon the how amount of white light mixed with the hue. So these are some terms. Then is a chromaticity. The sum of hue and saturation constitute the chromaticity of the color. Therefore, if there is no color, it is called achromatic light. Intensity. The amount of light actually present define the intensity. Therefore, the intensity is a physical quantity. If more light is present, the color is more intense. Achromatic light has only intensity but no color. Grayscale image have only two intensity. No one have an only intensity.
Sir,
Grayscale
one,
image.
one question here.
Hmm.
So at say 436, is there any
Hmm.
white light mixed or it is totally blue, the hue?
No, huge total blue. Total blue. Okay, it is a primary color. No other color is mixed with that.
Okay.
Luminance. This perception of color is the quantity known as the luminance of brightness. For example, given two color of the same intensity, such as blue and green, it is perceived that blue is much darker than green. Why blue is much darker than green? Blue has less wavelength. The ability of an object to the reflect light is the reflection of property of the object. The reflectance property determines the color of the object. Since we see those colors that are reflected back and not the ones that are absorbed. For example, an object that reflects green absorbs or other color in white light spectrum except green. So it depends upon the surface where the light falls. So you know that if a white surface are there, more light is not absorbed. So it is written that there are about 6 to 7 million, sorry, million cones in the human eye, and they are responsible for recognizing the color. So we already know that 6 to 7 million cones. There are rods and cones, you recall, and 6 to 7 million cones are present. Nearly 65 of the cones recognize red, 33% is sensitive to green, and only 2% is to blue. Red, green, and blue are known as the primary color, and nearly all other colors are seen as a combination of these primary color. That is, this concept you know that is a this is a cones are responsible for recognizing the color in our eye. However, there is a difference between the primary color of light and the primary color of pigment. The primary color of light are red, blue, and green, and they can be added to produce the secondary color of light that are yellow, magenta, and cyan, which are known as CMY. That is, you know that yellow is formed by using red and green. Magenta is from red plus blue, and cyan is formed green plus blue. So the primary color of pigment are said to be those that absorb a primary color of light and replace the other two. Okay, so the primary color of pigments means that those that are therefore in this case the primary color are cyan, magenta and yellow, while the secondary color are red, blue and green. You see there is a CMI model for standardization in 1931. The Commission International and CIE define specific wavelength for the three primary color. Red is 700, you see, blue is 430.58, it is about 436. So that is why it is written 436 in our picture slides. Green was 546.1 nm. So this primary color has specific uh, wavelength. The amount of red, blue, and green required to form a color are known as its stimulus values and are denoted by X, Y, and Z. How amount of these three colors are required to form another new color? Given that X and Y and Z are the stimulus coefficient which define a color. If we define X, Y, and Z are the relative values of the primary color, then these values can be formed by X equal to X by X plus Y plus Z, and Y by Y X plus Y plus Z, and Z equal to Z by X plus Y plus Z. So it is obvious that X plus Y plus Z equal to 1. So we know that if we specify color as a composition of X, red, and Y, then given that value of X and Y, the value of Z, blue, can be computed as G equal to 1 by 1 minus X minus Y. So if we subtract from 1, we will get the another value Z. You see, that's an example. Will be more clear. Consider the coordinate of a warm white is 0.45, 0.4, and the coordinates of the deep blue is 0.15 and 0.2. Find the percentage of the three color red, green, and blue on it. So we first find the uh, trichromatic coefficient XYZ at the point of warm white x equal to 0.45 and y equal to 0.4, which is given in the question. Therefore, the value of z is easily calculated because we know that the summation of x plus y plus z equal to 1. Subtracting from the sum of x plus y from 1, we will get the value of z. So z equal to here 1 minus 0.45 minus 0.4 equal to 0.15. So value of z equal to 0.15. Now we shall find the stimulus values for x and y and z. So x equal to x by x plus y plus z. So all the value you put, the new value of y is equal to 0 x. So therefore the percentage of each color would be as follows: x equal to 45% and y equal to 40% and blue equal to 15% in that color.
So why are the coordinates of deep blue are given in this?
Now, in the question it is given that is deep blue color is 0.1502 in a particular color. In a particular color, the warm white and deep blue is given. So
So
how
we
many
have,
percent?
sir, have we used its values in this question or not?
No, it is the question it is given. It is
I
given that
think
the
I think we have not used the values. We do not need to use the values of deep blue. We have only used the values of bomb white.
0.45.
We have used the values of 0.45, 0.45 and
Uh,
0.4, and we have not used the values of 0.15 and 0.2. So I think this is extra information given in the, and
hmm.
that's why I am asking.
Deep blue. We have only calculating the value warm white only. Hmm.
Sir, in that XYZ stands for what?
Sorry?
XYZ?
Actually, this is you make it x1 जो value जो distributes value you calculate the x1 y1 z1 because there is a distance between I have made all are a capital. Okay, so you make the value x1 y1 or z1. Okay, then x by x plus. So yeah, how can be x calculated x by something because x is unknown. X is left hand side there is x and on the right hand there is also x. So how do we put? So the sal of the find the test value x by x plus y plus z. So 0.45 is the x value. Y is equal to 0.40 value. So new value of x, y, z equal to 45%, 40%, and 15%.
So for Z, we are using that 0.15, right? Which is part of deep blue. Right?
Yes. Color models. So there are some color models used. You may heard about the RGB models, CMY models. So the principle of absorption of color or any model by human eye is known as color model. The human eye has absorption characteristics of color and recognize them as variables. Thus, the colors red, green, and blue are called the primary color of light. We have already discussed. The secondary color of light are produced by adding primary colors. For example, red and blue produce magenta color, red and green produce yellow color, and also green and blue produce cyan color. So proportion of primary and secondary color in appropriate amount produce white light. Let's see the RGB model. The RGB color is based on a Cartesian coordinate system, while the color subspace is a Q with axes representing red, green, and blue. A color in the RGB model is therefore specified as a three tuples RGB, where RGB represent the amount of red, green, and blue respectively present in that color. We have a Cartesian coordinate system. So the geometry of RGB color model in cube as a figure. There's a figure in the next slide, I think. It is assumed that all color values are normalized. That is, it is a unit cube and all values of R, G, and B lie between 0 and 1. So it is clear from the figure that it is model of a cube with the three axes of red, green, and blue. The grayscale value that is the model of a cube with three axes of red, green, and blue. The gray value lies in the diagonal of the cube, which joins the black and white color. But you see the color, you see. You see the black color, which is the origin 0, 0, 0. And the white color, you see, the coordinate of white color is 1, 1, 1. That is x value of that coordinate is 1, y is also 1, as well as z is 1. And you see the cyan color. In cyan color, that is a combination of blue and green. Blue is 1, green is 1, and red is 0. 1, 1, 0. It is not written there, but cyan color you write 1, 1, 0.
Cyan is 0, 1, 1, sir.
The combination of
cyan should be 0, 1, 1, sir.
0, 1, 1. Sorry, 0, 0, 1. So you see, white is 1, 1, 1. So this is a representation of a cube of different color. Blue is 0, 0, 1.
Magenta will be 1, 0, 1, sir.
1, 0, 1, yes.
1, 0, 1. Yes, 1, 0, 1.
Sorry, what is this 0, 0, 1?
0, 0?
Blue, that's blue.
Blue, that is blue, na? RGB, R is 0, 0, 1. Blue. You see the blue color is here.
R is
0,
0,
0, 1.
3 is 0, blue is 1.
Yes. You see the green 0, 1, 0 and red 1, 0, 0. Okay. RGB. Suppose magenta. Okay. Magenta, what is you see here? Green and blue. Is one color. So green means green is 1, blue is 1, red is 0. So this Q represent all the primary color and the secondary color magenta, cyano and yellow. Let us say a color image in the RGB model consists of 3 images. We know that RGB, these 3 images combine to form one composite color image of monitor. To convert an RGB image to a grayscale image, the intensity of the gray pixel is given by the average of RGB values. So if we want to convert RGB to gray level values or grayscale value, uh, that is your which value we have discussed lies between 0 and 255. So now the question is, how do we find the composite color in RGB color model at any point? For this, we follow the following step. Pixel depth in the number of bits usually represent each pixel. If an image in RGB model has 8-bit image in each of its 3 colors, then each RGB pixel has a depth of 3 image planes, 8 bit per plane and 24 bits. This gives rise to 22 4 colors. We fix the 3 color and let the other color to vary. Suppose we fix the R equal to 127 and let G and B to vary, then the color at any point on the plane parallel to GB plane would be 127 GB, where the other value lie between 0 to 1255. You see, there is a in an RGB image, the R and B component are at mid and the G component is at 1. Then which color would be seen by a person?
So I think there is a mistake in this one bringing out 1.2 in the bracket. I think there is a mistake.
No, it's fine. It's fine. It's fine. क्योंकि G को G/2 दो बार करके 1
अच्छा
G/2 बाहर ले लिया.
okay. That's fine. Thank you.
So it will be pure green with some gray components, sir. Mid gray plus half green.
Sir, G/2 and G are green, or is there some difference?
Sorry.
Sir,
Half,
G,
you see,
half G and G, are these two different things or the same?
G/2. It is actually a equation to perform R/2 plus B/2, which is a mid, but group component is there. So R plus B plus would be mid gray color, and half of G. It is a green color, pure green.
So
Half is a constant term. Half is a constant term.
So if is it G or G/2, the same meaning.
G. It is a G.
G. Thank you, G.
Okay, so it is pure green with some gray component are there, mid gray component there. Similarly, the CMY color or sometimes CMYK color model, RGB color, RGB model. So then CMY model. We know that cyan, magenta, and yellow are the primary color of pigments and secondary color of light. So the CMY model is a subtractive model, implying that it is subtract a color from the white light and reflect the rest. For example, when white light is reflected on cyan, it subtract red and reflect the rest. Okay, so when a white light is reflected on the cyan color, it subtract red and reflect the rest. Okay, while RGB is an additive model where something is added to the black to get the desired color. CMI is a subtractive model. Where RGB is additive model, it is a subtractive model. The conversion between CMI and RGB model is given by the equation below. That is CMY equal to C is equal to 1 minus R, M is equal to 1 minus B, and Y is equal to 1 minus G. So it is shown in a form of a matrix.
और यहाँ वन क्या है? व्हाइट.
Yes, white component or it is subtract from red, and one is white. You see,
One is
you will
white.
find this. Yes, you find. You will be more clear. You see the picture where the RGB values have been normalized. This spelling is T. It also gives a method to convert the RGB to CMI to enable printing hard copy. Since the CMI model is used by patient, you see the white color. The white color in the left hand side image is converted to black. That is subtracting from 1. That is 1 minus 1 is 0. So 0 is the black color.
समझा नहीं सर. सो लेफ्ट साइड आरजीबी है और आरजीबी जब ज्वाइन होता है तो व्हाइट बनता है.
हाँ, तो वो अब अगर हम सपोज व्हाइट कलर, लेफ्ट हैंड साइड इज व्हाइट कलर का कंपोनेंट सपोज 1. So corresponding value you see 1 minus 1 is 0. So in place of white there is which color? In the right hand side, black color.
अच्छा.
Similarly, you see the blue. So what is the component of blue? If you subtract from it 1, you will get yellow color.
अच्छा, व्हाइट से ब्लू निकालेंगे तो येलो आएगा.
आर और जी बच जाएगा ना, तो आर और जी बच गया यानी येलो आ गया.
हाँ, येलो आएगा. क्या है इसमें, क्या डिफिकल्ट नहीं है.
आरजीबी तीनों मिला के व्हाइट बन रहा है सर. उसमें से जो भी कंपोनेंट
ब्लू माइनस कर देंगे. हाँ,
CMY आ जा रहा है, इधर CMY मिल जा रहा है.
हाँ, it is clear. So you see in place of yellow there is a blue, and in place of blue there is a yellow. There is a yellow color in the left hand side, na? Isn't it? It is
Excellent
replaced by.
depiction, बहुत बढ़िया डिपिक्शन है सर.
So there is a blue color is there, and blue color is replaced by the yellow color. And you also see red color, and that color is which color? Cyano. Now which color? That is red color is replaced by.
That's
cyan sir.
Cyan, na?
Yes sir.
And another color is which is replaced by pink.
Magenta.
Magenta. It is magenta color. Yes. So magenta color is replaced by
pink. Right hand side actually is the printer version sir. Print में जो use करते हैं.
हाँ, print वाला जो है वो primary color. हाँ. They written that. It is, you see, it is written also that.
Yes sir.
This gives a method to convert from RGB to CMI to enable printing hard copy. Since the CMI model is used by printer and plotters. So it is a print hard copy of the RGB model.
सर ये राइट साइड में, जैसे लेफ्ट साइड में तो आरजीबी को ऐड करते हैं तो व्हाइट बनता है. ये राइट साइड में क्या CYM के को ऐड कर रहे हैं तो के बन रहा है? क्या हो रहा है?
नहीं, सब्सट्रैक्ट करते हैं. 1 से सब्सट्रैक्ट करते हैं ना.
अच्छा.
इट इज सब्सट्रैक्टिंग मॉडल. एक्चुअली CMI इज सब्सट्रैक्ट मॉडल. उधर RGB था वो एडिटिव मॉडल.
अच्छा, तो यहाँ व्हाइट से 1 निकाल दिए।
व्हाइट से, हाँ।
Sir, R plus G plus B is equal to white, but
Yes, equal to 1.
sorry,
RGB, R plus G plus B equal to 1, we know.
1 and CM, when we replace with CMY, then 1 minus CMY is equal to
It is written, you
0.
see. You see, C is equal to, yes, that is, suppose 1, C is equal to 1 minus R. अगर 1 से हम R माइनस कर दें, क्या रहेगा? B G रहेगा. So B plus G equal to C.
यस सर।
Blue plus green equal to cyano. Similarly, you see the M equal to 1 minus B. 1 मतलब क्या है? R plus G B.
उसमें से B हट गया सर।
जो B हट गया, तो B अगला क्या बचेगा? R G magenta. Similarly, you see the last one 1. Y is equal to 1 minus G. Okay, so similarly, the other color are formed. So so the RGB model, which white color is produced by adding the 3 primary color, red, green, and blue. But in CMI model, where the black is obtained by the sum of the cyano, magenta, and yellow. So the inverse relation between the RGB and the CMI model is also shown by these two images. In practice, black is obtained by combining cyano, yellow, and magenta. However, this leads to the muddy looking black. For publishing, the black color plays an important role. Therefore, CMYK color is color model. Black is added as the fourth color, where K stands for black.
यस सर, प्रिंटर में कभी कभी ब्लैक इंक खत्म हो जाता है ना सर, तो MYK मिल करके ब्लैक यूज करता है, लेकिन वो बड़ा बेकार दूसरे टाइप का ब्लैक होता है।
So CMYK color model.
वो दिस की स्पेलिंग नहीं थी सर, वो THSI मॉडल था सर वहां पे, जो आपका पिछला था ना सर। THSI जो है सर, वो दिस
THSI also gives us.
यस सर, यस सर, THSI मॉडल सर।
So a color model is very close to human color perception, which use the hue, saturation, and intensity component of color. When you see a color, we cannot describe in terms of amount of cyano, magenta, and yellow that the color contains. So in our, if you see that, so we cannot tell that is the amount of how much amount of cyano, magenta, and yellow color mixed with it. Therefore, the HSI color model was introduced to enable describing a color by its hue, saturation, and intensity or brightness. Hue describes the pure color. Saturation describes the degree of purity of that color, while intensity describes the brightness of the color or sensitization. In a grayscale image, intensity defines the gray level and shows HSI color model and wave color model. There is a figure you see. Okay, so you will view here that is how much intensity of a different color in a image. So white color is, you see, blue color in between that. So this is a graph, a VHS model. It shows the amount of different components. HSI color model is represent and its relation to RGB model. The HSI triangle shows slice from HSI solid at a particular intensity. So we may notice that the hue, saturation, and intensity values required to form HSI color space can be computed using the RGB values. So this is color.
ये इम्पोर्टेंट सर, आता है एग्जाम में ये वाला डी,
बहुत बार आता है, मैंने देखा इसको, आपने नहीं था, मैंने ऐड किया। हाँ एक्चुअली नहीं था
हमेशा
मैंने
आता है।
इसको actually it is a transformation, image transformation. डिस्क डीएफटी आता है, डीसीटी आता है एंड द डिफरेंस भी आता है. So
Yes.
please recall, actually it is a not a new topic. Transformation, we have already discussed image transformation from one domain to another domain. Please recall, uh, we have discussed the spatial domain. Basically we are familiar with the spatial domain in XY form, XY, and we know that it is a two-dimensional XY, that is your location and grade level values, intensity values. Uh, but we have another domain which actually deals with the signals. That is your frequency domain. So your discrete Fourier transform is used to image processing to transform an image from in spatial domain to the frequency domain, revealing its frequency content. Okay, frequency content is revealed, so there is no difference. But it is used to, as the word transform is there, it is used to transform from one form, one domain to another domain. That is in a spatial domain or pixel form, which has two components, location and intensity value, to the frequency domain, to the signals. This allow for tags such as image filtering, compression, and enhancement by manipulating the frequency component, which correspond to different type of image feature like edge, high frequency, and smooth areas, low frequencies. So basically, the frequency domain, in frequency domain, it is easy to perform such type of operation on that image. So that is why it need to convert one domain to another domain. To convert this, the topic or the technique is used, that is called discrete Fourier transform. How it works? Transformation. How DFT works? The DFT converts a finite sequence of pixel values into a set of frequencies. For a 2D image, it involves applying 2D DFT to separate it into horizontal and vertical frequency component. Let us see what is frequency component. The resulting frequency domain image shows the distinct frequencies. The center of the image represents the low frequency, smooth and general features, while the area further from the center represent high frequency, suppose fine detail, edges and noise. So we already please recall some filter we have already discussed: smooth filter, low pass filter, high pass filters, mean filter, median filters. Okay, so uh, then magnitude and phase. The DFT output is a complex valued image where the magnitude of each component represents the strength of that frequency and the phase represents its position. Let us see what is the some application of the application in image processing, that is application of DFT in image processing. Image filtering. By manipulating the frequency domain image, we can filter out unwanted component. So filtering is easy. In case it is a convert to a spatial domain, sorry, frequency domain. High pass filter. This removes low frequency to enhance edge and fine details. And as the name suggests, low pass filter, it removes high frequency to smooth the image and reduce noise. Please recall there is a mean factor, mean filter and max filter. It removes there are salt noise, pepper noise. We have already discussed in the previous classes. Image compression. So the DFT can be used for compression by identifying and discarding less important frequency component. So there are two processes we know: quantization. The frequency coefficient are quantized to reduce the number of bits needed to store them, especially for high frequency coefficient, while keeping the most important low frequency ones. The DFT provide insights into the image structure. For example, the presence of prominent frequencies can can repeatedly pattern to textures within image. So this is a application of DFT. Similarly, it has some actually some mathematically equation are there. Okay, mathematical equation are there. So this equation is not related to the question जो आता है बस ये था what is it DFT, write its components, how it is differ how it is differ from DCT. Similarly, sometimes you will get question inverse discrete Fourier transform. As the name suggests inverse, it works exactly opposite to DFT. The inverse discrete Fourier transform reconstruct the original image from its DFT, which represent the image in the frequency domain. So you know that in DFT means it is converted to a spatial domain to frequency domain. Suppose you after you perform some operation, you want to return to your back form, that is in spatial form or spatial domain, or spatial domain, then we can use IDFT. By applying the IDFT to the frequency domain data, which consists of both the magnitude and phase information, the IDFT converts it back to the spatial domain, yielding the original image pixel. So it is now converted to the form of pixels. So IDFT exactly plays exactly done what does the DFT do, which is opposite to DFT. The process is crucial for image filtering, and distortions after manipulation are performed on the frequency domain. As I discussed that, so you first convert to your spatial domain to frequency domain. Now it is easy for manipulation. You made the manipulation, and suppose the manipulation is done. So now you can convert that image which was in which domain, frequency domain, to spatial domain after manipulation. So that is the need of DFT, that is convert to spatial domain, then make some manipulation, again convert to the spatial domain. Working. Frequency domain representation. The original image, as you know, which was a DFT, so it most in originally most in which domain? Spatial domain. So the original image in the spatial domain is first transferred into the frequency domain using DFT. You know that DFT converts the image which was in the spatial domain to frequency domain. This process reveals that the frequency present in the image, with low frequency representing the broad area of the color and high frequency representing the fine details of the edges. So it has different frequency, and from the frequency we have discussed that, you will know that which is high frequency. Please recall we have seen a profile picture there. Please recall we had a slide which represent the corresponding frequency profile.
Yes, it was there.
So then make manipulation. In the frequency domain, we can modify the image by filtering it. So once it is converted to frequency domain, so manipulation is easy. We have predefined tools or to manipulate the frequency domain image. Suppose we have to remove the noise. So eliminate the high frequency component to blur the image and remove noise. Sharpening, enhance high frequency component to make edges and details sharper. So now you make any manipulation once it is converted to frequency domain. Similarly, the IDFT is then applied to the modified frequency domain data to reconstruct the image. So once it is manipulated, the manipulation is done. Now you convert to which domain? To the original domain, that is spatial domain. So the 2D IDFT is separable, meaning it can be implemented as a 1D IDFT on each row of image, followed by another 1D IDFT on each column of the resulting image. So then DCT. ये भी आता है क्वेश्चन.
यस सर, अल्टरनेट DFT और DCT अल्टरनेट आता है, कभी जो है डिफरेंस आ जाता है.
कंपैरिजन भी है उसका. In image processing, the discrete constant transform is a technique that converts an image spatial pixel data into frequency component, which is used most notable by image compression. Uh, uh, I have not written actually the mathematically equation. If what you see, you will see
नहीं,
in
उसमें
DFT.
लिखना पड़ता है सर, एग्जाम में तो लिखना पड़ता है सर।
हाँ लिख सकते हो, लेकिन ये स्लाइड में नहीं है या कुछ इधर उधर हो गया तो मैंने इसको ये कर दिया। यू
नॉट
इट
एन
मे
इशू,
राइट।
नॉट एन
हाँ सो इन
इशू।
हाँ इन पीडीएफ फॉर्मेट यू मे राइट.
सर सर
You can see there are some mathematical term out there. It separates an image into a combination of cosine waves at different frequencies, concentrating the most important visual information. Low frequency component into a few coefficient and making it efficient from lossy compression algorithm like JPG, which is discarded less important high frequency coefficient to permit application. Spelling. एप्लीकेशन का स्पेलिंग गलत है, वो कहाँ से आ गया पता नहीं।
Sir, excuse me, sir.
हम्म
Sir, if we see the last year's paper in DCT and DFT, we are having questions to solve
हाँ
mostly.
दे नहीं लगता न्यूमेरिक। हाँ अच्छा न्यूमेरिकल आता है उनके
न्यूमेरिकल
फॉर्मेट।
आता है सर, न्यूमेरिकल।
Yes,
ठीक है
sir.
देख रहे। देख रहे सब कुछ क्वेश्चन लाएंगे, यूज करेंगे।
2-3 एग्जाम दे दीजिएगा सर, मतलब
ठीक है ठीक है।
लास्ट ईयर से ही दिखा दीजिएगा सर, या फिर कोई अपना
Uh,
होगा आपका।
sir, I
हम्म।
have that paper.
अच्छा
If you want,
ओके
I
सेंड
can.
मी सम। हाँ हाँ सेंड मी दैट, आई विल सॉल्व
Okay,
इट
sir.
एंड आई विल
I'll
डिस्कस इन
I'll
द नेक्स्ट।
send it to you. Because it is coming like consecutively. I think not consecutively, but alternate years it has come.
ओके 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 आई विल डिस्कस इट।
Okay, sir.
Image compression, the most common application as seen in JPG format for reducing file sizes of image. And filtering, DCT can also be used for image filtering by the performing symmetric convolution, a different form of convolution that is more efficient in the frequency domain. And these are the difference. Actually, I have a DFT and DCT PDF difference. There are some point of view. So I will also share that. Not DCT. Actually, the main difference is that the discrete cosine transform is performed for image compression like JPG because it converts energy more efficiently into fewer coefficient and produce only real values. While the DFT use both sine and cosine, result in the complex values and is less suitable for compression. So basically, DCT is for the as we know that is for image compression only. Not only, but it is better. It is a suitable compression for DCT for image compression. But DFT, discrete Fourier transform, use both sine and cosine, result in compressing values and is less suitable for image compression. But DCT only contain your which values? The real values. DFT is more general and widely used for uh, spectral analysis, while DCT use of cosine function and specific boundaries condition make it more efficient for lossy compression algorithm. So, but we have a box and in categorized in different with respect to different component. That component is in a PDF format, not viewed viewed properly. So I have not given here. So I will share that PDF in PDF form. 1 minute. 1 minute. Is it viewed? Clear, not written. 1 minute.
हाँ अभी दिख रहा है सर।
तो बड़ा कष्ट करना पड़ेगा। Not clear written, no? No. Okay, I will see it. It's not clear, Shin, na? चलो चलो. Okay, so item name and or any issues, any problem you can share now, or any question.
Share this the one PDF you are talking about, sir, and this PPT as well, sir.
Sure.
Sir, I have shared a compiled document which has all the questions from the previous years, from 22 to
Okay,
24.
okay. I will see.
Yeah.
And I will solve some numerical question of DF10 shape.
Oh, okay, sir.
DF10 this is okay. Okay, actually your MCS 230 class 230 का class आज last था नहीं? I think.
Yes, sir.
Yes, sir.
So I will okay 10-15 minutes I will take the class from MC 231. Okay, so we'll discuss in that class. Okay, so after class is over, MC class,
Okay,
we'll
sir.
take 20-25 minutes to discuss that.
Okay, sir. Okay, sir.
Okay.
सर आज 3 o'clock से क्लास है ना हमारी नेक्स्ट वाली
नहीं नहीं,
शायद
1 बजे से, 1 बजे
आज
से,
नहीं है शायद.
1 बजे
1
से,
o'clock, 1 o'clock, 1 बजे से.
1 बजे से.
आज
मेरा नहीं है.
आज 1 बजे से है ओके ओके
हाँ,
1 बजे
प्रोजेक्ट
से
है,
लेकर इट इज नॉट
प्रोजेक्ट
माइंड.
वाला 232.
प्रोजेक्ट वाला है 232
रतन सर का
है आज.
ओके थैंक यू सर
Okay, thank you.
थैंक यू सर.
Thank you, sir. Thank you,
थैंक
sir.
यू सर. सर.
Okay, thank you.
सर अटेंडेंस हो गया.
Thank you, sir.
असाइनमेंट किन्हीं का अपलोड हो रहा है क्या?
हाँ भाई, सबका हो रहा है.